Hi everyone, and welcome to this video going over lesson 32, area of triangles, rectangles, and parallelograms. So let's get started. In the last video, we found out that we can find the area of a rectangle by multiplying the length times the width. If you notice here, I have a bunch of parallelograms, and we drew a line from the top of the parallelogram to the bottom of the parallelogram so that we created a right angle. And it looks to be a little triangle. If we were to cut along that dotted line and remove that triangle and move it to the other side, notice how it fits in perfectly and transforms my parallelogram into a rectangle. I didn't change the amount of space of the parallelogram. I simply moved it around and showed that a rectangle with the same base and height as a parallelogram will have the same area. So the area formula for a parallelogram matches that of a rectangle, so all I have to do is length times width. So for this parallelogram, I have a length of 12 and a width of 5. So 12 times 5 would get me an area of 60 centimeters squared. So once again, I can remove this triangle piece from the parallelogram and move it to the other side to form a rectangle with the same dimensions. So this rectangle has a length of 20 feet times a width of 10 feet, which would give me an area of 200 feet squared. So notice in each parallelogram, I used the base length of the parallelogram and the height line that went from the top and the bottom and made a right angle. I did not use the side length of the parallelogram that is slanted. That does not accurately reflect the height of the parallelogram. So in each case, I have to multiply the base and then find the height that goes from the top to the bottom and makes a right angle. So the area of a parallelogram is base times height, or length times width. So in number 1, I have a base of 12 yards and a height of 11 yards. So 12 times 11 will give me an area of 132 yards squared. If you're wondering why we don't have to know this length outside of the parallelogram, it's because I only want to know the area of the space inside of the solid parallelogram. The dashed part outside is just to show us the height. That is not actually space in the parallelogram. So we can ignore that. 12 represents the base of just the solid parallelogram that I'm trying to find the area of. In number 2, my base is 8 inches and my height is 2.1 inches. So 8 times 2.1 will give me an area of 16.8 inches squared. For number 3, I have a base of 7.6 centimeters and a height of 6 centimeters. Multiplying those together, I get an area of 45.6 centimeters squared. And then in number 4, I have a base of 12 inches and a height of 7.3 inches. So multiplying those together, I get an area of 87.6 inches squared. So in each of those, it was really easy to identify the base and the height because they only gave us those two measurements. But in the next two problems, we have to make sure that we pick the height that is perpendicular to the base. So in A, this is actually a triangle. So don't forget that the area of a triangle formula is base times height divided by 2. I see that 16 is my base, and notice how 9 is the line that is perpendicular to the base, and so that represents my height. So I will be doing 9 times 16 divided by 2 since this is a triangle, which will give me 72 units squared. In B, I have a parallelogram. I can tell because I have two pairs of parallel sides. And the area formula for a parallelogram is base times height. My base is 26. And notice how 14 is the line that goes from the top to the base and is perpendicular to the base. So 26 times 14 give me an area of 364 units squared. Let's see how we can use our knowledge of finding area to answer a real-world problem. So Lisa is designing a countertop for her new apartment. The tabletop is a composite figure that consists of a rectangle and a parallelogram. Tabletops cost $8.50 per square foot. How much will Lisa's tabletop cost? So, in order to find out how many square feet is Lisa's tabletop, we first have to find the area. And then once we know the area, we can multiply the cost of the tabletop per square foot times the area. So let's start with finding the area. Because this is a composite figure, I'm going to take the area piece by piece using shapes that I know how to find the area of. So I'm going to start with this rectangle right here. I see that my base is 6 and my height is 5, and so multiplying those together will give me an area of 30 feet squared for this rectangle. And now I have to find the area of this parallelogram. Well, I see that the base is 3 feet, but I don't know what the height is. What I can do is, because this side is 5 feet, I know that this side is 5 feet. And notice how I have a right triangle with a hypotenuse of 5 feet and a base of 3 feet. From the trig chapter, I know that I can use the Pythagorean theorem to find missing sides of right triangles. So I'm going to set up 3 squared plus h squared equals 5 squared so that I can figure out what the height of this parallelogram is. 3 squared is 9 and 5 squared is 25. I'm going to subtract 9 to either side to get 16 and then square root both sides, and I get that the height is 4 feet. And now that I know the height of this parallelogram, all I have to do is base times height, which gives me an area of 12 feet squared for the parallelogram. Now that I know the area of each piece, all I have to do is add them together to get the entire area. So the area of the entire tabletop is 42 feet squared. And now that I know the area, all I have to do is multiply by 8.5 to find the cost of the tabletop. And that'll be $357. The last thing we're going to talk about in this video is how to find the area of a non-right triangle. The issue with a non-right triangle is there is no line that's perpendicular to the base, so that we don't know what the height is for this triangle. So what I'm going to do is I'm going to draw in my own height line. I know that the height line goes from the top of the triangle to the base of the triangle and makes a right angle. And I'm going to label this H for height. I'm going to try to come up with a formula for the height using SOHCAHTOA. So from angle A, I'm going to label my opposite side, my adjacent side, and my hypotenuse. And notice how I have my opposite and hypotenuse lengths. So according to SOHCAHTOA, if I have O and H, I'm going to use sine. So sine of angle A is equal to opposite over hypotenuse. The opposite is H, and the hypotenuse is C. And after I set up my trig ratio, I put a 1 under my sine and cross multiply. 1 times H is H, equal to C times the sine of angle A. With this equation, I now know how to find the height of my triangle. So with our area formula, the area formula for a triangle is always base times height divided by 2. And now that I know what the height is of my triangle, I can substitute this in for height in my formula, which will give me b times little c times the sine of angle A, all divided by 2. And this is the area formula for non-right triangles. And I want you to pay attention to the letters that we're using. Little b, little c, and angle A. Notice how that gives me an SAS. Because remember, the labels are arbitrary, meaning we didn't necessarily have to use angle A. We could have used angle B or angle C, and the sides would have changed accordingly. But the main idea is that we look for an SAS, two sides with the angle in the middle, such that the two sides will be little b and little c, and we will find the sine of the angle. So let's try this. The diagram shown represents tabletop ABC. The tabletop has side lengths 5 feet and 7 feet. The angle between the two sides, angle A, has a measure of 49 degrees. Compute the area of the triangular tabletop to the nearest tenth. So notice how I have an SAS. So for my two sides, I multiply them together. And then I multiply that by the sine of the angle in the middle and divide by 2. And if I plug all of this into a calculator, make sure to be careful with your parentheses. This will give me 13.2 feet squared when I round to the nearest tenth. So in this video, we found that the area formula for a parallelogram matches the area formula for a rectangle, so just base times height. And we can find the area of non-right triangles with this formula up here, using two sides and an angle in the middle. Please let me know if you have any questions, and I will see you in class.